Good morning. So this is Coordinate Proofs Part 1. Today we're concentrating on this video. I'm concentrating on Step 3, identifying the coordinates of the corners of the figure. So it means we want to use variables, and we want to use coordinates that make the computation as simple as possible. So we're going to concentrate on that one point in this video. So here we have some example problems. Go down here right to the problems. We need to find the missing coordinates. We got to figure out what goes into these spots. Now here's some key points that you need to know and need to remember. If the point is on the x-axis, the y value is 0. If the point is on the y-axis, the x value is 0. If there is symmetry, more than likely what you have to do is either have them be the same value, one positive, one negative, or you're going to divide it by 2. Other big rule, all horizontal lines have the same y value. And all vertical lines have the same x values. So if I have 2 points that are on the same horizontal line, I'm going to have those 2 points have the same y value. If I have 2 points that are on the same vertical line, they have to have the same x value. So now this comes into play into this problem here. We'll start with number 1 up here in the top left. Here I have this triangle. Notice I've got congruent marks on the triangles. That means I have some symmetry going on here. That means from P to the value that's straight underneath the R, it's the same distance over to the other side. That's going to be useful to us. Now, let's take a look at point Q more specifically. Point Q is right here, and it's on the x-axis, which means its y value has to be 0. So I know it's the point that ends in 0. Now we need to figure out the x value, and this is where the symmetry part comes in, because if it's 2a to get right underneath R, it's going to be another 2a to go from underneath R over to the Q. So altogether, I'm going to add those two values together, and I get 4a. So it gets me a 4a, 0 point. Now let's look at number 2 here, the right triangle in the upper right-hand corner. I have a triangle that's on the x-axis. Again, notice we have congruent marks. That means they have to be the same length. When we look at C and B, we have all of those points values there. Notice they have the same y value because they're on the same horizontal axis. And point B is 2a. So that means this bottom side is 2a units long, which would mean the side going up to the on the left also has to be 2a units long. That can come into play here. So now we've taken care of everything from the B. Going up, we know it's 2a units long. Notice the x value in both the C and the A are the same at 0 because they're both on the y-axis. Now, to figure out the y, I have to make sure it's 2a units up. Well, that's going to be my value there, 2a. So point A is at 2a, 0. Okay, let's look at this bottom problem now. I'm going to call it number 3, and I'm going to do this one up in red. Okay, problem 3. Notice we got 3 congruent marks. All 3 sides are the same. This is an equilateral triangle. Since this is an equilateral triangle, every side has to be 2b units long. Everything is 2b units long. Now, that gets interesting because everything's 2b units long. How am I going to figure out the values for the z value up here at the top? Well, the first thing I'm going to do is I'm going to drop in that line that goes straight down the middle. That's going to be a line of symmetry. So that means this whole length of 2b across the bottom has to be split up in 2 parts. I would have to have 1b on one side and just 1b on the other side. So that tells me that the x value is b. Now, for simplicity reasons, we can just say the other side point is C, so it's not the same value as the B. Or we can use the whole Pythagorean theorem thing and figure out what that is. I could take A, which would be the side I don't know, and I would have B, and then my C is 2B. So I could say 2B squared would equal, I don't know what it's called, I'm going to call it Y then, Y squared plus B squared. So now if I do that, Y squared would equal, or plus B squared equals 4B squared. So Y squared would equal 3B squared. So Y must be the square root of 3B squared, which is the square root of 3B. So instead of saying C, I could call that the square root of 3 times B. Either way would work. I think the book will go with C. So that's how you place a point or figure out the missing points on a coordinate plane.